What you're seeing now is a small drone being blown by a leaf blower. The drone on top is being controlled by a traditional PID loop, while on the bottom is the same exact drone being controlled by our custom machine learning model. As you can see, our model is able to more effectively combat the large amount of wind disturbance. Here we perform a similar demonstration. What you see now is how a traditional PID loop recovers after being shoved. Notice it takes a while for it to recover back to the marked set point. Now we activate our model and move the camera for a better angle. It also takes a second to settle to the correct height when switching between the two coordinate frames, which I forgot to wait for before harassing it. Now that the transition to the model is over, you can see how well it recovers from being shoved. Notice how much quicker it settles back to its set point. Here's another side-by-side to show you the difference between the two. It's visibly obvious our machine learning model outperforms the traditional PID loop, even though the PID loop had to be tuned specifically for this size drone. And it's not like the model only performs under ideal conditions either. Here's a chart showing good vibrations on the left. This chart on the right are the vibrations of the flight we just showed you. From these charts, we can tell that the model is operating under very suboptimal conditions with a ton of sensor noise. In addition to this lower level model for controls, we have also made a high level machine learning model to handle navigation, which can be seen in the window on the right. We built a pipeline that can take in data from all types of sensors and feed it into this model. This top-level model can then handle commands from code or an RC controller to perform autonomous navigation and obstacle avoidance. This means you can tell it to go from point A to point B without worrying that it'll run into a power line, tree, or even a moving object. But the most valuable part of these demonstrations is that it's the same exact model that is able to fly all of these drones with no modifications. This means we can take the same flight controller using our model, slap it on a drone 10 times as big, and immediately fly it under much different conditions. So what we have effectively made is a one-size-fits-all drone controller that is higher performance and far easier to use than the industry standard. Currently, we are working to package these components together in a cohesive way to let people try it out. If you are a person or a company interested in trying out this software, please reach out to us and let us know what platforms you use and how you'd like to interact with it. We want to work with as many people as possible to make sure we focus our energy connecting to the platforms and controllers people actually want to use. So please reach out, and thanks for watching.